Hi everyone, in this video we are going to talk about the current distribution in a balanced Wheatstone bridge. So first of all we shall try to know what do you mean by Wheatstone bridge and what do you mean by a balanced of it, right? So Wheatstone bridge is a combination of 4 resistors like we have discussed earlier. PQ, we had done a video on this in the previous case. You can just look into that in the playlist of current electricity. So Wheatstone bridge is a combination of 4 resistors arranged in the format of a bridge which has 4 nodes like this, 4 junctions like this. Between 2 junctions a galvanometer is connected. Between the other 2 junctions a battery, a source of a known EMF is connected. This is how it is there, right? Now if the bridge is in a balanced state, this is a Wheatstone bridge. Let us see what do you mean by a balanced Wheatstone bridge. The bridge is said to be balanced when current passing through galvanometer equal to 0. So look at these junctions. This is one junction. This is another junction. Between these 2 junctions galvanometer is connected. So what do you mean by the current passing through the galvanometer is 0 means between that 2 junctions, that 2 nodes or junctions, potential difference is equal to 0. There is no potential difference and hence there is no flow of current. So though there is a physical galvanometer which has some resistance G, it has no significance in the running of the flow of the current. So if you draw an equivalent circuit to this, when the bridge is in a balanced state, you can redraw that as P, Q, R. Simply you need not draw that galvanometer itself. This is an equivalent circuit. So this is the positive plate of the battery, this is the negative plate of the battery. Let us see how does the current flows. From the positive plate a current I starts, here is a junction. The current get distributed. Some current will go to this P, some other current will go to this R. After reaching this junction that I1 will go this way, I2 after coming to this junction will go through resistance S. So at this junction I1 and I2 will join, it becomes again I as per the Kirchhoff's current law. Current is always conserved, it comes back to the negative plate of the battery and that will be keep happening. So it's very clear that current passing through P as well as the Q is the same. Similarly, current passing through R and S is the same. That means they are in series. So if you draw a further simplified circuit, it could be like this. P, Q, R, S. Just for an understanding, I am redrawing the circuit cell. So here current I starts. After reaching this junction, it becomes splits as I1 and I2. Here both of them joins and comes back. So P and Q are in series. So the effective resistance of this P and Q, because they are in series, is P plus Q, right? P plus Q. The effective resistance of this R and S, because they are in series, is R plus S. So if you have to draw an equivalent circuit again, so the equivalent circuit of that could be like this. It could be P plus Q, it could be R plus S, and this is the battery. Again the resistance P plus Q is in parallel with the resistance R plus S. Between them the current is shared, the voltage is same. Therefore the total resistance of the circuit, that's the first thing I want to calculate. The total resistance of Wheatstone bridge. Of course, Wheatstone balanced bridge when there is no current passing through galvanometer is because these two are in parallel. You remember the formula for the resistors, two resistors in parallel? R parallel equal to R1 R2 by R1 plus R2. This is R1, this is R2. So that is equal to P plus Q into R plus S by P plus Q plus R plus S. That is the equivalent resistance of the entire Wheatstone bridge. Now say for example, you want to calculate how much is this I1 is or how much is this I2 is. You want a specific value, like what is your next question is? What is the value of I1? How much is I1 is? Or what's the value of I2? How it is shared? That's what I want to calculate next. Let us see how can we calculate that. That's also simple stuff. Look here. This is what your I1 is. This is what your I2 is. So it's very clear that this P plus Q combination and R plus S combination is in parallel. In parallel, voltage is distributed, you know. So what you can say? In parallel, voltage is same. I said voltage is distributed. I'm sorry earlier. Voltage is same, but current is shared or distributed. How it is distributed? You can say the total voltage of the circuit equal to voltage across the combination of this one, P plus Q, right? So I know the formula for the voltage, total current and total resistance is voltage across P plus Q is, I can again write a formula, current across that I1, resistance of that is nothing but equal to P plus Q, because that are the resistances of P and Q in series. So we have already calculated the value of R total earlier. What is that? Like I am showing here, P plus Q into R plus S by this value. P plus Q plus R plus S is I1 of P plus Q. So this P plus Q and this P plus Q can be cancelled. You want the value of that I1, that implies I1 equal to I of R plus S by P plus Q plus R plus S. So you got the value of I1 as I1, look at the diagram, I1 is equal to total I by R plus S of, that means the other resistor, right? So similarly, if you write a formula something like, what else you can write? You can write directly the equation, but you can derive if you want. Say for example, V total is equal to V across R plus S also. What is V total is? I total into R total. This is the value of that R total, that is P plus Q into R plus S by P plus Q plus R plus S is V across R plus is I, that is I2, resistance of that is R plus S. So again this R plus S can be cancelled. So I can get the formula I2 as I of P plus Q by P plus Q plus R plus S. This is how I can calculate the respective voltages, voltage distribution and the currents, right? But of course in the further video where we are going to go into further a little more detail, but I will discuss this aspect also, but I would like to further see what happens when the bridge is in a balanced state. What happens when the bridge is in a balanced state, or what shall be the values of that resistances P, Q, R, S, so that bridge gets balanced or not, right? So this is what we are going to talk in the next video. Stay tuned for that and come and see in the case of a balanced bridge, from where to where the current flow, and in the case of an unbalanced bridge, from where to where the current flow, and how that is being shared, right? Thank you for watching.